Hello, students. How are you today? I'm Mr. Abu Mustafa, and this is our lesson, which named Real Numbers. Real numbers. First of all, we have to start with brainstorming with this. Can you imagine what is the mass of the orange ball here and here? We can make it as an equation. This orange ball Rx and this orange ball 1x. So x and x and x and x is 4x plus 5 equals to the other side 17 plus x. Okay? This is an equation. We will move x to x and number to number to make a balance of the scale. So for x minus x, this x is positive. Go to the another side in a negative sign, equal 17, and 5 will move to the another side by negative sign. So 4x minus x, 3x will be equal 17 minus 5 equals 12. 3x equal 12. Divide 3 here and divide 3. 3 cancelled by 3. So x will be equal 12 over 3, or 12 divide 3 equals to 4. So x will be equals to 4. Okay? Okay. In our lesson today, we will study real numbers. Firstly, we took many sets on the previous years about sets. The first one is counting numbers, C. It equals 1, 2, 3, 4, 5, 6, 7, 8, 9, infinite. This is called counting numbers. But counting doesn't include zero. So we took the another or the next set, which named natural numbers. Natural numbers equal 0, 1, 2, 3, 4, 5, 6, 7, 8, infinite. So the difference between counting and natural, counting doesn't include 0, but natural included 0. After that, we took, or we wanted to express about the number sub-zero. The numbers which sub-zero is negative number. So we need a set included positive number and negative numbers. So 0 here in the middle, 1, 2, 3, 4. This is the right of 0. And here, negative 1, negative 2, negative 3, negative 4. This is sub-zero, like temperature in the some of countries. It's maybe negative 5 or 5 sub-zero, and so on. This set, we called it integers, but its symbol is Z. Z means integers, and the integers equal 0 in the middle, 1, 2, 3, 4, infinite, and negative 1, negative 2, negative 3, negative 4, and infinite. This is integers. So Z is the biggest one until now. and N and C is less than the other sets. So C is subset from N and N subset from Z. When we wanted to represent these or all these sets, we will represent it by Venn diagram C inside N and all of these inside Z. After that, in Prep 1, we took rational number. Why we took rational number? Q. Rational number, we use it when we wanted to express about fractions, decimals, mixed numbers, percentage, and all of these. It's equal A over B, such that A belongs to integers and B belongs to integers, but B doesn't equals 0. For example, 3 over 4, it's belongs to Q because 3 belongs to Z. This is the first condition. 4 belongs to Z. This is the next or the next condition. And 4 doesn't equal 0. 3 belongs to Z, 4 belongs to Z, and 4 doesn't equal 0. Another example, 0.3. This is belongs to Q. We can write it as 3 over 10. Our condition, 3 belongs to Z, 10 belongs to Z, and 10 doesn't equal 0. So this is rational. Another one, 2 belongs to Q. Oh, 2? Yes. You have to know any integer numbers, its denominator is 1. 2, we can write it 2 over 1. So 2 belongs to Z, 1 belongs to Z, and 1 doesn't equal 0. That's mean all counting and natural and integers, all of these subset of Q. Q, its mother or their mothers, okay? Okay. We stop here on grade 7 or Prep 1. But when I give you an equation just like that, x power 2 plus 1 equals 2, 3. Let's solve together. Say with me, we will move positive 1 to the another side, negative 1. Okay, so it's x power 2 equals 2, 3 minus 1, 2. This is x power 2. So I wanted to take square root for all sides. Square root cancelled by power 2. So x will be equal root 2. Root 2, what is the value of root 2? I don't know. I can't get the square root for 2. And the square root, we took the square root for 4 equals 2. Square root 9 equals 3. Square root 25 equals 5. Because 4 and 9 and 25 is a perfect square numbers. Again, 4, 9, 16, 25, 36, 49. All of these numbers perfect square. What is the meaning of perfect square? Has a square root. What is the meaning of have a square root. Means this is perfect square, means 4 is a product of two similar numbers, 2 times 2. 9 is a product of two similar numbers, 3 times 3. 16 is a product of two similar numbers, 4 times 4. 25, 5 times 5. 36, 6 by 6. 49, 7 by 7. So the square root of 49 equals to 7 because 49 is 7 times 7. This is the perfect square. We have to know. So root 2 belongs to what? To Q? No. This is a new set which named a rational number. A rational number. A rational numbers. Okay? So the first type of numbers which belong to a rational number is the square root for non-perfect square number. Let us see. This is the sets counting natural integers rational or irrational numbers. The first type of a rational number, the square root of non-perfect square number, such that root 2, root 3, root 5, root 7, root 6, all of these are rational numbers. Okay? Okay. The next type of numbers that belongs to a rational number, the cube root of non-perfect cube numbers. How? What is the perfect cube numbers? Perfect cube numbers like 1, 8, 27, 46. All of these called perfect cube. Why these numbers called perfect cube? Because this number a product of three similar numbers. 1 is 1 by 1 by 1. And 8 is 2 by 2 by 2. And 27, 3 by 3 by 3. 46, 4 times 4 times 4. So the cube root of 46 equal, we will take 1, 4. The cube root of 27, we will take only 1, 3 equals 3. The cube root of 8 equals 2. The cube root of 1 is 1. Okay? But the second type of numbers which belongs to a rational number or Q dash is the cube root of non-perfect cube numbers, such that cube root 5, cube root 9, oh, 9 equal 3. No, 9 is 3 times 3, two similar numbers. But the cube root to the number, we find the product of three similar numbers. So 9 must be a product of three similar numbers to be or to have a cube root. Okay? So the first type is the square root for non-perfect square and the cube root for non-perfect cube numbers and the number pi. What is the pi? Oh, pi is a ratio between circumference of the circle and its diameter. This is pi, which equal 3.141592654. This value, pi, is a ratio between the circumference of the circle and its diameter. The fourth type of numbers, which belongs to irrational numbers, Q dash, is golden ratio. Golden ratio is a scale to determine the beauty of the building. How this building is a beauty or beautiful building. And this is concerned to or related to decoration. This scale belongs to decoration. So we have 4 types of irrational number. Okay, only 4 types of irrational numbers. We have to save it on our mind. Square root of non-perfect square. Cube root of non-perfect cube. Pi and golden ratio. It's simple. Okay. Let's talk some exercises about that. Okay. Which of the following numbers are rational and which are irrational? Give the reason. Negative 12, rational or not irrational? Negative 12. Rational because it belongs to Q. It achieve 3 conditions. Negative 12 over 1. This is the same. Negative 12 belongs to Z and 1 belongs to Z, and the denominator doesn't equal 0. Root 25 belongs to a rational? No, not belongs to a rational. Why? It's a square root, but 25 is perfect square. So root of 25 equals to 5 because 25 equals 5 times 5. So it belongs to Q. Root 13, square root 13. 13 doesn't have a square root because I don't have two similar number. When I multiplied it by each other, it will be 13. So 13 belongs to a rational number. Q dash, a rational numbers. Okay. Root negative 27 belongs to a rational number. No, wrong. Why? We took, there are no square root for negative numbers. I can't put a negative number under square root, but I can put it under cube root. So 27 equal negative 3 by negative 3 by negative 3. Product of 3 similar number equals to negative 3, the cube root of negative 27. But square root of negative 27, you will take it on secondary on the imagination numbers, but not now, okay? So it's not rational, not irrational, not real numbers. Okay. Let's complete 2 and 2 over 5. 2 and 2 over 5 belongs to rational because it's a mixed number. We can make it an improper fraction by times down plus up. The denominator as it is 5. 2 times 5, 10. 10 plus 2, 12. This is a fraction. Numerator belongs to Z. Denominator belongs to Z. Denominator doesn't equal 0, so it belongs to rational numbers. Okay. Negative cube root for 10. Do we have product of 3 similar number? Give me 10? No, we don't. So it belongs to irrational numbers. This is a decimal, so 0.125. It belongs to rational numbers. 3.6, a decimal, belongs to cube. That's clear? Okay. If you have any question, leave me the question in the comment, please. Let's complete. Okay. Just a moment. Okay. Let's complete. Find two consecutive integer between which each of the following numbers lies and determine its approximate location on the number line. He gave me a rational number like root 11. He wants me find integers before root 11 and integer after root 11. How can I solve it? Okay, the question is root 11. Let us see. 11. What is the number before 11 and after 11? But we want the number before 11 which has a square root. The number before 11 which has a square root is 9. And the number which after 11 which has a square root. Okay, 16, 12, not have 13, 14, 15, 16. Take the root for all numbers. Root 9, root 11, root 16. Okay, this is root 11. The question. When you want to find root 9, you have to find product of two similar numbers give you 9. 3 times 3. So the square root is 3. 16, 4 by 4. So square root for 16 is 4. So root 11 lies between 4 and 3. Okay, we want to represent it on the number line. Okay, this is the number line. Root 11 near to root 9 more than root 16. So this is root 9 and root 11. I will make root 7 near to root 9 more than root 11. But you have to use your ruler and pencil to be accurate, okay? We have to take another example to understand. Cube root 20. Cube root, this time not square root. We have cube root 20. So I have to find number perfect cube before 20 and a number after 20 cube root. Okay? Okay. The number before 20 is 8. It's a perfect cube. And the number and the number after 20 is anyone know? Root 27. Okay, okay. Let's talk cube root for all sides. Okay. Cube root for 8, 2. Cube root for 20, it doesn't has any cube root. It doesn't have any cube root. Cube root for 27, 27 is 3 by 3 by 3. So it's 3. So cube root 20 between integer 2 and 3. We have to draw number line. Here 2 and here 3. 20 near to 27 more than 8. 20 near to 27 more than 8. So I will make it near to 3 because 3, this is the root of 20, cube root of 27. Here, cube root 20. Okay, how I know the perfect cube? How I know the perfect cube? Firstly, one perfect cube because it 1, 1, 1, 1 times 1, 1 times 1. 2 times 2 times 2 equals 8. So the next perfect cube number is 8. The next 3 by 3 by 3 is 27. So the next cube or perfect cube number is 27. The next 4 by 4 by 4 equals 64, and so on. Okay? Okay. This is 2 question which we solve now. And this is the Venn diagram which clear us the relation between Q rational and Q dash irrational. So Q union Q dash equals a new set which named R. So when you union Q and Q dash, it will be equal R. But Q intersect Q dash equal phi because no common numbers between Q and Q dash. There are no common numbers between Q and Q dash. This a set and this another set. No relation between them. Okay? So intersect between them equals phi equals phi. Okay? But are real numbers equal Q and Q dash. Okay? Okay. This is the Venn diagram for real numbers. R equals Q union Q dash. Q intersect Q dash equals phi. C subset from N, subset from Z, subset from Q, all of these subset from R. Q dash alone subset of R. So this is rational, integers, natural, and counting in a place, and Q dash in another place. Union of all of these equals R. Okay? Okay. The last question, put appropriate symbol belongs or not belongs in the empty box. Firstly, this is a recurring numbers. Recurring numbers. How recurring numbers? When you write on the calculator 1 over 3, you will find it equal 0.3333333. Instead of write all of these 3, we write 0.3 and dash over 3. That's mean 0.3333 means 3 is repeated and repeated and repeated all the time. Okay? Okay. Recurring number is rational number. Recurring number is a rational number. So the numbers which repeated also belongs to rational number. So 0.63 means 0.63636363 and so on. Belongs to Q dash? No, doesn't belong to Q dash. It belongs to Q. Root 5 belongs to R or not belong? Huh? Anyone know? Yes, belong. Why? Because R included Q and Q dash. And root 5 belongs to Q dash, and Q dash subset from R. Absolute value of -4 and N. The first perspective give you that not belong, but you have to solve the absolute value. -4 will be out 4 when you find the absolute value of negative 4, it's equal 4. So 4 belongs to n or not? Belongs to n, very good. Cube root of 3 and 3 over 8. I can't solve it as it is. I have to convert it to improper fraction by times 3 down plus up. 3 and 3 over 8. Okay. 3 times 8. Firstly, denominator doesn't change. 8. 3 times 8, 24. 24 plus 3, 27. So we have cube root for 27 over 8. I will get cube root for the denominator alone and the denominator alone. So cube root of 27 is 3. Very good. And 8, cube root for 8 is 2. 3 over 2 is a fraction, belongs to q. Huh? You remember? Because its denominator belongs to z. Its denominator belongs to z. Denominator doesn't equal 0. Very good. So you want, if it's belong to z, not rational, okay, doesn't belongs to z. Why? Z, all z is a whole number, not doesn't have any fraction. But this an improper fraction. 3 over 2 is a fraction. Belongs to q, but not belongs to z. Cube root 3 belongs to q? No. Why? Because it's a cube root for non-perfect cube numbers. 3 non-perfect cube numbers. I can't have any cube root for 3. So it's not belong to Q. Root negative 1 and real numbers. It's belong. No, it's not belong. Why? Because negative 1 is negative. And under square root, we said this doesn't belong to any sets we studied. Because this we will study it in secondary, inshallah. Okay? Okay. I'm very happy for being with you. I want you to think about this equation until the next session and the next episode in YouTube. Make subscribe, make like, and share to share the benefits for all the students. Thank you and goodbye. See you soon. If you have any question, leave me the question on the comment. Bye.